So we start a new chapter, calorimetry, and an understanding of heat. Basically in physics, this is what we do when we study thermodynamics. And one of the fundamental concepts that need to be understood in terms of heat is the kinetic molecular theory of matter, which states that basically all matter is made up of atoms and molecules, and these atoms and molecules have energy. So what do we mean by that? So if you look at the atoms and molecules in all of the matter which is there in this universe, roughly about 5% of the universe is made up of this kind of matter, which is made up of atoms, which are made up of protons, neutrons, and electrons. So this matter contains energy. What kind of energy is that? The matter always, in terms of the atoms and molecules, vibrate about a mean position. Okay, so this vibration is something of an inherent property of these atoms. They seem to have this kind of energy in them. That energy is basically what we can state as kinetic energy, but more accurately we should say it is thermal kinetic energy. Okay, this is not the kinetic energy of the body itself, of the mass itself moving. Okay, that's a different kind of kinetic energy. This is what is called as the thermal kinetic energy, in which the molecules vibrate about a mean position. Now we can discuss what happens if the vibration increases or the vibration decreases. Okay, so when the body is given an external source of energy, then the vibration can increase because the molecules will absorb the energy and they will start vibrating more and more about its mean position. So its mean displacement would increase. Now we say that this body, or at least the molecules and atoms, have greater internal energy, and conversely, if they lose energy to the surroundings, they are losing energy, and therefore their internal energy decreases. If you take a body that is made up of atoms and molecules and they are all vibrating about a mean position, if you provide energy external energy to this body, then the atoms and molecules vibrate more, therefore increasing its internal energy. If you allow it to cool down, it loses energy to the surroundings and therefore it reduces its internal energy. This internal energy is what is termed as heat. Okay, and now we will move on to the next part of it, which is discussing how do we measure the internal energy. Okay, so measuring internal energy. It's a simple thing in terms of understanding how internal energy is measured. So if you have a hot object, let's not make it too hot, so I'll give it a orange color. So this object has some internal energy, and say that you touch this object. Okay, so somebody touches this object. Now what happens at the surface of contact between the object and your skin is basically that let me just draw this part. Is that the atoms and molecules which make up this object, because of the contact at the surface, loses some of their energy to the atoms and molecules that make up your body. Okay, so the atoms and molecules that make up your body now gain internal energy and they start vibrating more, and naturally when that happens, through the nerve endings and so on, a sensation of heat is transferred to your brain, and then the brain decides what to do with that. If it is a cold day and you are touching something that is warm, you have a good sensation, so you want to keep your hand there, like holding a hot coffee mug on a cold winter morning. But at the same time, if the temperature is too high and the brain senses that there could be tissue or cellular damage that is happening because of the amount of internal energy that is being gained by you, then it will force your muscular system to withdraw from that heat. Okay, so we are able to measure the temperature in this way. On the other hand, if you have a cold body and you touch it, okay, so there is a cold body and you touch the cold body, okay, then what happens is the reverse can happen. So let's say that this is a block of ice. um, this is a block of ice. Then what is going to happen is that instead of the internal energy going from the object to you, which is what happens in this case, right? In this case, the energy will go from your body into the ice. Okay, because the ice is at a lower temperature than your body. So therefore, your body has higher internal energy. So therefore, the internal energy will flow in the opposite direction. And again, your sensory system will work to say that this is a cold object. If it feels nice, like in a hot summer day, you will keep it there. If it is excessively cold, then you will withdraw your finger. So that is the way in which internal energy can be sensed by our body. And the same idea can also be used to make an objective measure of the temperature of objects. Okay, so the device that we use to do this is of course a thermometer. Okay, a thermometer, word made of two parts, the thermos part of it, that is heat, and meter, measure. So something that measures the heat or the internal energy of another object. So let's examine briefly how that happens. Okay, how a thermometer works. So the simplest kind of thermometer that is commonly in use is what is known as the mercury in glass thermometer. Okay, so say there is some water, okay, inside a container, and let's say that the water has a certain amount of temperature. Okay, now you insert a thermometer into this, a mercury in glass thermometer, which is basically a thin tube that contains mercury trapped inside it. Okay, so there is a thin tube with a very small bore, and within it there is mercury. Okay, now what happens is that in the area of contact between the mercury, glass and the water, okay, so that part is what we have to examine now. So there is water, there is a glass surface, and then there is mercury inside that. Okay, so now what happens at this surface is that two possibilities. One is that the internal energy flow can occur in one of the two directions. Okay, so it can flow from the water to the mercury, or it can go from mercury to water. When will it go from water to mercury? It will go from water to mercury when the water has greater thermal energy than mercury. So let's say that the thermal energy of water is greater than the thermal energy of mercury. So in that case, the flow is going to go from thermal energy from the water through the glass into the mercury. So the mercury molecules then gain this thermal energy, and naturally, because when thermal energy is gained, the volume will start to rise. Okay, and the volume will rise up to the point where this thermal energy is going to reach an equilibrium. Okay, when the equilibrium is reached, then there will be no more transfer of thermal energy, and then this point where it stopped, that point refers to the shows that the thermal energy of the water and the thermal energy of the mercury are the same. Okay, so that is how we can measure the thermal energy of an object, of a body, using another substance like mercury. Alcohol can also be used, which will absorb the energy and then it will indicate how much thermal energy it has. So one of the first thermometers that were made by using this concept was the Galileo thermometer. Okay, so Galileo was the one who first invented this kind of device. And the Galileo thermometer quickly gained some use, especially in the field of medicine, in medicine, where one of his friends realized that this fact that the thermometer can be used to measure the temperature of a person's body, which can tell whether this person is unwell or well. So that fact could be used to do that. Okay, and then for about 100 years of 100 years or more, we were using the Galileo thermometer, which was actually an unwieldy device because it had to be taken in separate pieces to the place where the patient was. Then water had to be filled into the small tube. Initially, they used water, and then it was also cumbersome to use because the person, you have to either get the person to hold the thermometer, which did not give always a good indication because their hands could be cold. So you had to use some part of the body like the armpits or something like that, where the internal temperature of the body can be better indicated. The more difficult problem with this use of the thermometer was that while the thermometer rose to a certain level to show that the temperature of the body is of some value, the heat of the body is of some value, we did not know whether that temperature indicated a healthy or an unhealthy person, because it was just a tube in which the water rose to different levels. So first it had to be calibrated by using a normal person who is not unwell, and then that point had to be fixed, and then it had to be used on the person on whom you want to do the diagnostic, and then based on the rise of the water in the water in the tube, you have to say whether the temperature is higher than normal or lower than normal. Okay, so therefore the use of this kind of a device was not very common, not as common as it is today. So two things were required. One is a thermometer had to be made which was efficient, not cumbersome to use, durable, and can be carried in a small container. The second thing was a scale had to be developed in order to measure the temperature of the person. Okay, so so this development was made by two people, Anders Celsius and another person, Gabriel Fahrenheit. Okay, and you can immediately see the scales at which we measure temperature comes from the name of these two people, the Celsius scale and the Fahrenheit scale, from their surnames. So Anders Celsius and Gabriel Fahrenheit independently, one in Europe, one in no, both were in Europe only. They developed the scale which we currently use for measuring the temperature of the object. Okay, so this measure of the heat is what came to be known as temperature. Okay, and the temperature scale that was proposed by Anders Celsius eventually was a scale in which he measured. So the story goes something like this: having found out the temperature of having found out a good way to encapsulate mercury inside a container and make it something that is neat and nifty, Anders Celsius wanted to put a scale also on it. Apparently, this was done because a customer of his, these people were actually instrument manufacturers, a customer of his who was a botanist said that I use your thermometers inside my greenhouse, but I do not know how to compare the temperature between different times. So if you can tell me, if you can develop some kind of a scale of temperature, which will tell me whether it is, what the temperature is. Is it like a hot sunny day or a warm winter day or a cold winter day or a warm sunny day? Something like that. Give me a scale so that I can look at the level of mercury in it and I can immediately take a decision of what to do. So Anders Celsius was thinking about developing this scale, and it was a cold winter night, and it was snowing outside. So he got the idea that why don't I use the freezing point of water, the temperature of snow basically, and then the boiling point of water to mark the two high ends of the thermometer, because temperatures usually do not go far beyond these limits. Okay, so he apparently ran out of his house, stuck the thermometer into snow, and whatever level it came to, he marked that. The story goes that initially he marked that as 100 degrees Celsius, and then he boiled water, put the thermometer into it, and then marked that as 0 degrees Celsius for some weird reason. Okay, but of course later these 2 points were switched, and then uh, this temperature, the temperature at which water boils, um, boiling water, became 100 degrees Celsius, and 0 degrees Celsius became the temperature at which ice melts. Okay, and that is how we came up. So he took that scale and he just simply divided it into 100 parts, and each part became whatever, 10 degrees Celsius, 20 degrees Celsius, and so on, until 100 degrees Celsius, and that is how the scale was developed. So this is the story of how the thermometer was invented, and now we have two concepts that we can understand about heat. One is the heat of an object, which is the measure of its internal energy, and temperature, which is the measure of this heat. Okay, and with these two concepts we should be able to further understand what the coming concepts are going to be.